Every single keyboard you've ever used, your phone, your laptop, your gaming keyboard, is arranged in a layout that was never designed for speed. It was actually designed to slow you down. And once you understand why, you'll start noticing this exact same pattern everywhere else in the modern world. Let's get into it. Back in the 1870s, an American inventor named Christopher Sholes was working on one of the first commercially viable typewriters. The design used metal arms called type bars, each one stamped with a letter, that would swing up and strike an ink ribbon against the paper whenever you pressed a key. Here's the problem. If two type bars sitting close together got struck one right after another too quickly, they'd physically collide and jam midair before they could fall back down. Typists using early prototypes kept getting stuck mid-sentence, arms tangled together, having to manually pry them apart. Sholes needed a fix, and he didn't have the technology to solve the actual mechanical issue, so he solved it a different way. He redesigned letter arrangement itself. Instead of arranging letters alphabetically, or placing the most commonly used letters in the easiest positions, Sholes analyzed which letter pairs appeared together most often in English, and deliberately spread those pairs apart across the keyboard. If two letters were unlikely to be typed in quick succession, they'd end up far away from each other. If two letters were likely to jam, he separated their type bars inside the machine. The result was a layout that intentionally made typing slightly less efficient, in exchange for making it mechanically reliable. That layout became known as QWERTY, simply named after the first 6 letters on the top left row. In 1873, the Remington Company, one of the largest manufacturers in America at the time, licensed Sholes' design and began mass-producing typewriters using the QWERTY layout. Remington had the manufacturing scale and distribution network to dominate the market almost overnight. As typewriters spread into offices, schools began teaching typing using the QWERTY layout because that's what was available. Professional typists built entire careers around muscle memory trained on this specific arrangement. Within about 2 decades, QWERTY wasn't just one option among many. It was effectively the only layout anyone learned. By the early 1900s, typewriter engineering had improved dramatically. Better spring mechanisms, improved type bar design, and eventually electric typewriters entirely eliminated the jamming problem QWERTY was originally built to solve. This is the part most people don't realize. The layout kept existing long after the reason for its existence disappeared, because by then, switching would have meant retraining millions of typists, replacing equipment across every office and school in the country, and abandoning decades of institutional muscle memory. The cost of switching had become larger than the inefficiency of staying. In 1936, an academic named August Dvorak, alongside his brother-in-law William Dealey, spent years studying hand movement efficiency and designed an entirely new keyboard layout. The Dvorak simplified keyboard placed the most frequently used letters in the English language directly under your strongest fingers on the home row, and organized vowels and common consonants so that far more typing could happen without your fingers ever leaving that middle row. Independent studies conducted over the following decades showed that typists using Dvorak could reduce finger travel distance by a significant margin compared to QWERTY, and many reported being able to type faster with less fatigue after retraining. Despite being objectively more efficient by nearly every measurable metric, Dvorak never replaced QWERTY. Millions of typewriters and later computer keyboards already existed with QWERTY hardwired into their manufacturing. Every school, office, and typing class had already built its curriculum and equipment investment around QWERTY. Switching an entire population of typists would have required simultaneous retraining and equipment replacement on a scale no single company or government was willing to fund. This phenomenon has a name in economics: path dependence, sometimes described through the idea of a technological lock-in. Once enough people and infrastructure commit to one option, even a worse one, the accumulated cost of switching can permanently outweigh the benefit of the better option. Once you see this pattern, you start noticing it everywhere. VHS beat Betamax in the home video format war during the 1980s, despite Betamax generally offering better picture quality, largely because VHS licensed its technology more widely and reached more manufacturers and consumers first. Once video rental stores stocked more VHS tapes, the format won, regardless of technical superiority. The same logic applies to why certain software becomes an industry standard even when better alternatives exist, why certain measurement systems persist in specific countries, and why some outdated infrastructure remains in use simply because too much has already been built around it. Today, you're typing on a layout that was engineered in the 1870s to intentionally slow down typists in order to prevent a mechanical problem that stopped existing over a century ago. Alternative layouts like Dvorak and the more modern Colomac layout still exist and are still used by a small dedicated community of typists who've chosen to retrain themselves. But for the overwhelming majority of the world, QWERTY remains the default. not because it's the best solution, but because it was simply the first one that stuck. Every system you interact with every single day is carrying the weight of decisions made decades, sometimes centuries ago, for reasons that often no longer even apply.